We continue our review for your Algebra 1 semester exam with Chapter 7 information today. Chapter 7 started with the properties of exponents. Properties of exponents. So we are asked to completely simplify each of the following expressions. Completely simplify the given expression. And starting with number 15, it says x to the third times x to the 12th. X to the third times x to the 12th. We had a property that said when I multiply things that have the same base, we want to add their exponents. 3 plus 12 gives us 15. X to the 15th is correct. Again, this is when we are multiplying. If we are adding things, one x cubed and 2x cubed. Remember, that's 3x cubed. When we're adding, we don't do any, we combine like terms. But when I multiply, that's when I add their exponents. Question number 16. Number 16 says x to the 0 power. We had another property that said anything to the 0 power is equal to 1. Number 17, we are given 3 to the negative third power. 3 to the negative third. Negative exponents get moved down to the bottom. So if they're on the top, they get moved down to the bottom, and we make the exponent positive. So instead of 3 to the negative third, that's the same thing as 1 over 3 to the third. Three to the third means 3 times 3 times 3. 3 times 3 is 9. Times 3 gives me 27. 1 over 27. If we happen to have a negative exponent on the bottom, you move it to the top. So like if I had p squared over r to the negative fourth, that r to the negative fourth gets moved to the numerator and becomes positive. So usually that's, we have it on the top and we move it to the bottom, but if it's on the bottom, we would move it to the top and make it positive. Number 18. 18 is the power of a power property. Power of a power. X to the 8th to the 4th. X to the 8th to the 4th. Power of a power. We multiply exponents. 8 times 4 gives me 32. X to the 32nd power. Number 19. 19 says x to the 24th divided by x to the 6th. X to the 24th divided by x to the 6th. When we multiply, we add exponents. If I divide with the same base, they're both x. When I divide, I subtract exponents. 24 minus 6 is 18. Answer is x to the 18th power. Number 20. Number 20, I have 3 times x times y to the negative fourth, all to the fourth. As long as I'm only multiplying or dividing in here, I can distribute this exponent. So we are going to raise each factor to the 4th power. So I have 3 to the 4th power. I have x to the 4th power. And I have y to the negative 4th to the 4th power. So I raise each piece to the 4th. 3 to the 4th is 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. X to the 4th just stays as is. This looks a lot like number 18, power of a power. We multiply exponents there. Negative 4 times 4 is negative 16. We should never have a negative exponent in our answer. Y to the negative 16th, we are going to rewrite that as 81x to the 4th. Negative exponents get moved down to the bottom, and we change to a positive exponent. 81x to the 4th over y to the 16th. Number 21. 21, x to the 7th times x to the 4th, all to the 4th, divided by x to the 8th. X to the 7th times x to the 4th, that in parentheses to the 4th, divided by x to the 8th. Take them one step at a time. Always start inside the parentheses. When I multiply, what do we do with the exponents? Add. 7 plus 4 is 11. So I simplify inside the parentheses to x to the 11th. Everything else I rewrite. Here I have power of a power. Power of a power, we want to multiply. 11 times 4. And now I'm dividing. When we divide, what do we do with the exponents? We should subtract them. 44 minus 8 gives me 36. X to the 36th power. Number 22, last one like this where we're using the properties of exponents. We are dividing two things. We've got 35x squared y to the 10th divided by 7x to the 6th y. When we divide, we subtract exponents. These are not exponents though. 35 divided by 7. We just divide those like we typically would. 35 divided by 7 is 5. X to the 2nd divided by x to the 6th. These are exponents this time. So we are going to subtract 2 minus 6 is negative 4. Subtract the exponents. If there's no exponent written there, that's understood to be a 1. Y to the 10th divided by y to the 1st. 10 minus 1 gives me y to the 9th. Negative exponents should not be in our final answer. Any negative exponents get moved down to the bottom. So I have 5, y to the 9th, that stays on the top. Those are positive exponents. This negative exponent gets moved down to the bottom and made positive. Next type of problem, numbers 23 and 24, ask us if we have exponential growth or exponential decay. So those were all properties of exponents. The rest of the types of problems we're dealing with exponential equations. Exponential equations which have the general form y equals something, we'll call it a, times b to the x. The x is in the exponent. We can tell if it's growth or decay based on the number that we are raising to the exponent, so the b value. If b is greater than 1, we have exponential growth. If the thing that we are raising to the x is less than 1, that is when we have exponential decay. So number 23, y equals 2/5 times 5 over 2 to the x. We don't care about the a value, the value out front. We're looking at the thing we're raising to the x, which in this case is this 5 over 2. 5 over 2, that's 2.5. That's bigger than 1, so we have growth. Number Number 24, y equals 5 to the x. We are raising 5 to the x power. 5 is bigger than 1. So again, we have exponential growth. Suppose we had like y equals 9 times 0.3 to the x. 0.3, that's smaller than 1. That would be a decay problem. And the last problem here is a story problem. In your notes, you don't need to write down every word, but the minimum we should write down, we start with 82 fish. 82 fish are introduced to a pond. The number of fish triples every year. And we want to know how many fish do we have after 2.8 years. 82 fish are put into a pond. That number triples every year. We need to know how many we have after 2.8 years. So we have an exponential growth problem. Should be growth because it's tripling, it's getting bigger. The basic exponential equation, y equals a times b to the x. That's what we should be thinking through. That's what we're starting with. A is the number that we start with, which in this case is 82. We start with 82 fish. B is the growth factor. Our growth factor, if it triples, is 3. And X is the number of times that it triples. So if it triples every year, after 2.8 years, it will have tripled 2.8 times. And now it's a calculator problem. Make sure you know how to type that expression into your calculator. We've got 82 times 3 to the 2.8. It says to round to the nearest fish, so 1777.2. So to the nearest fish, 0.2, we round down, so 1,777 fish. A couple other things on these types of problems I want to make sure I mention. The B value is the thing that sometimes gives us trouble. If it says something like it grows by 5%, to find B, we are going to start with the 100% that we currently have and add the 5% to get 105%. And then we need to change it to a decimal. Decimal point's right there. We always change it to a percent to a decimal by moving the decimal point 2 places to the left. So in that case, my B value would be 1.05. If it goes down instead of goes up, if it like decreases by 5% each year, we take 100% that it's at now and we subtract 5%. Each year we would be left with 95%, and then again we change it to a decimal. We would move it 2 places to the left. B would be 0.95 in that case.